to you our distinguished guest, Professor Pramod Kumar from India, from GLA University in Mathura, and he's currently, beside researcher, scientist, he has position of Dean of International Relations and Academic Collaborations. Also, he's professor at Department of Computer Engineering and Applications. He's also chairperson in Departmental Research Degree Committee. And he's also the person who is senior member of IEEE organization, also Association of Computing Machinery and Computer Society of India. I will tell that he's a very good researcher. He published many papers in his field. His current Kirsch index is 20. Also, he visited many places, many universities, mostly in Asia and Europe. It's many of them, I will not name them. And also he is PI and co-PI of 3 grant funded by government in India. What else? Also, his research interest is machine learning, and today's talk will be devoted to machine learning, especially now a hot topic due to popularity of AI, and machine learning is like one of the tools of AI. And also he do research in data science, especially like data mining, fake news detection, web information retrieval. And today's talk will be about, I will just read this. This talk will be discuss basic concepts such as type of algorithms, how evaluation works, on the efficiency of algorithms, and application in the field of information retrieval and natural language processing. Okay, thank you, and I will give you let's start talk. And also tradition of very long tradition that we appreciate your visit, we giving flowers as an appreciation of your visit.
Thank you so much.
Thank you. Thank you very much for coming. And it's really great pleasure and privilege to have this distinguished speaker about, because being a physicist, I am not quite familiar with this AI learning or computational tasks, so that is why I invited him. Currently we are dealing with some issues regarding hard computational issues, and it's very difficult to solve by classical computer. Even AI cannot be used for solving these issues. It's another problem how to define the hard computational issue. How hard is hard for you is another talk. So today he is expert in designing of machine learning algorithm or software for solving or dealing with this hard computational problem. So we are looking forward to this. Thank you. Thank you very much.
Good afternoon, everyone. So, am I audible to the last one? Yeah, thank you. Yeah. So, first of all, my sincere gratitude to Dr. Pramod KUMAR for inviting me to deliver a talk here. Because of his support and regular follow up to me, like you come and deliver a talk, introduction to my team. So, I am very happy. Thank you. So, today I am going to give a talk on machine learning basics, applications, and few things related to what is hard computational problem and how we can, what are the various approaches to solve it. So I will start from the basics. So we all are aware machine learning, we all are human beings. So since our childhood, through the environment, through our parents, colleagues, we are going to learn the things, and the kid, you can see in the picture, like different kind of the fruits is going to shown to him, and he's going to remember, okay, this is fruit, this is apple, this is guava, this is orange, cherry or other fruit. But for machine is not going to have the intelligence, so machine is going to train with the help of data sets. So data set, we will discuss the different type of the machine learning algorithm. So data set is supposed to be labeled or unlabeled data, and then the basis of the various features of the input, the output is going to label, and after training and testing data set, the machine is able to classify it like this is apple or this is cherry or orange. So this you can see, like if you have a machine already trained, but again whatsoever machine we are going to train, that is going to train to behave in a certain manner. If it is not behaving in a certain manner, it is going to treat as a noise and it's supposed to be throughout. So one very famous quote given by the Alan Turing is a renowned computer scientist. What we want is machine that can learn from the experiences. And long back, Bill Gates, co-founder of Microsoft, gave a breakthrough in machine learning would be tens of Microsoft. The co-founder of Google search engine, Larry Page, he also gave a very important quote on artificial intelligence would be the ultimate version of Google, the ultimate search engine that would understand everything on the web. It would understand exactly what you wanted, and it would give you the right things. We are nowhere near doing that. However, we can get incrementally closer to that, and that is basically what we work on. So we all are aware, like we are going to have a lot of data. So the world will store 200 petabytes of data by 2025. So we are in year of 2025. So every minute on the internet, lot of data is going to generate. Here also we are going to have the cameras, so we are going to take a pictures. Again, data is going to store on the cloud or local machines. Every minute, huge data is there. So what is web? Web is World Wide Web. So Tim Berners-Lee in 1990 he coined the term of World Wide Web, and there is a text which we call hypertext. So hypertext means the text which we are going to write on the computer machine. So the hyper means having the features of beyond the normal text. The text which we write on the diary or notebook is the plain text, but the hypertext is going to have the feature of hyperlinking, bold, unbold, changing the typeface, font size, so many things. So in 1990, in Sierra Lab Geneva, Tim Berners-Lee wrote the first hypertext transfer protocol. Actually, I'm the man of computer science, so but this will give you the idea about the whole thing. So he wrote the first hypertext transfer protocol, and that is required to transfer the text from client to server with the help of client-server architecture. Then he wrote the first language which we call hypertext markup language. He also wrote the first web browser. Now these days we are doing a lot of web browser, but again to access the internet we need a web browser, and also he wrote the web server where the website is going to host. Yeah, so one term is very important, information retrieval. So information retrieval, everyone wants to get the information on the internet or on the web. So it deals with the representation, storage, organization of an access of information item. And the representation and organization of information should provide the user with easy access. So that is why we all are interested to use Google search engine. Whenever we need some information, we don't need to remember the website's name also. Now Google, like Chrome, is going to have the searching facility inbuilt in the browser. So what is the problem of information retrieval? So the problem is to find important relevant document to the information need. Whatever topic you want to have some need, you are going to get to the, and certainly it is going to retrieve from the large document set. So there is an information need, Then we are going to have the information retrieval system, and it is going to have the corpus database, and from the database it is going to retrieve the high rank documents. So we can take one example, like let me tell you, the information retrieval example can be the Google search engine, digital libraries, IEEE Explorer, SQL size commerce. So they are able to fetch the specific kind of the information. Suppose, like I want to get information, and this conference is a very biannually conference our university is going to organize. So last conference is called 2023. Now these days on the Google search engine we are going to get the query suggestion. This is our need, like we want to know about the XCON 2023. It will suggest, and this will give like that the answer. So our need was to get information on the XCON 2, so registration details and so many other informations. So one thing, Google search engine, whenever we are going to write any query, and we are free to write in our own language, personal, comfortable. So it is going to search from its own database. Please, it does not do the real-time searching. It's have its own server. So this is the broad architecture, high-level architecture of any information retrieval system, or you can say for Google also. That paper I'm not discussing. So like for any information retrieval system, there is a web. On the web servers, all the websites, millions or trillions of websites is going to store. Now there is an important component called the web crawler. What is the web crawler? It is an agent, a script. It is going to provide the knowledge base to the search engine. Now you all are aware, like every website want to come on the search engine, because search engine is a medium of knowing what you are doing. So crawler is going to provide the crawling facility. They are going to have the database, and all the sites want to come to the search engine. So they are going to provide the access, and they are going to store in the database. But one thing you have to remember, any search engine like Google or Yahoo or Bing, they are not going to store the complete website. Otherwise the size will be enormous, big database. So they are going to have the mirror copy of the pages with certain information. So one term comes in the picture that is also the important component of any search engine, like inverted index. So what is this inverted index? So you know that in the books we have the table of content, chapter 1, page number this, chapter 2, name of the chapter 3, like that. But you think for this Google search engine fast, why it is going to provide the answers in less than about say thousands of seconds, whatever. Why? Because they are going to access from its cache server, and they are going to store it. So they don't use this normal index, they use the inverted index. Inverted index means like on say English language websites, the website is going to have the keywords. Every web document is going to have the keywords, words, and there is a specific structure for it. And then, so what they are going to do in the inverted index, they are going to have the list of keywords on the left hand side, and these keywords are occurring in which websites. What is, whether they are occurring in the domain name, whether they are occurring in the title page, where they are occurring in the image caption, whether they are occurring in the bold, H1, S2 size, like that. So like that, the structure of inverted index is there. So by that, it is fast searching. Because if they are going to put trillions of websites and then their information, it will take a much higher time to fetch the data. Then we are the user, we are free to write a query, but please remember one thing, Google is not going to directly process that query. It is going to do the query parsing and expansion. It is going to do a lot of operations on the query, but we as an end user, no worry about it, the interface. So if query parsing and expansion is going to carry out, I will show what are the different operations they do on the query parsing and expansion, and then they are going to have the system query. So this system query is going to used in the retrieval and ranking algorithm. Like you already have heard the name of the Google page ranking algorithm. That is the beauty of this search engine. Like most of the time, if the data is available on the search engine, Google search engine, they are going to provide a list of answer sets. So many answer sets. But always we are going to say top 10 or top 5, or it depends on the need of the high rank document is on the top one. It also going to show the sponsored. Sponsored means they are going to have pay to that company. But these are the organic results which is produced by their own algorithm. So this ranking algorithm is going to use the inverted index and parse query, and then you are going to show the answer sets. We are going to click on the answer set, and then in real time manner that page is going to open. So I have already asked you the web crawler is a very important part. So I asked like they have their own database. So crawler is going to provide the knowledge base to the search engine. Now every sites want to come on the Google because people are going to know about them, what they are doing, what kind of business they are doing without knowing them. So there is a need of a protocol which we call the robot.txt protocol. So this robot.txt protocol is a text file which every website is going to have. Let me tell you, if you are going to create your own website, you may be not so important or you don't want to, but for a professional website, every website with the name of their domain name, like quantlase.com, then /robots.txt. So this file allows search engine to download the pages. So I will show you this file for, like this is the example. This is whitehouse.gov /robot.txt file. So White House, you all are aware, like the President House official website. So this hash comments we are going to call as the statements, comments. Then there is called user agent. So here is the user agent : star. Then it is mentioned crawl delay. Crawl delay means because there are many crawlers, many search engines is available, not Google, Yahoo, Bing, so many research based. So they are going to say, because every website is going to have their own function. So they are going to put a delay of 10 milliseconds. Though two servers can fetch their pages same time. Then there is the disallow policy. Disallow means now any website, they are going to have so many things, not only the accessing the information. Because now it's the era of the web-enabled software development. Internet banking, so the bank employees, bank users, and different sections is going to do the business. So all content should not come on the Google search engine. So thereby this robot.txt disallow policy come in the picture. And I also show I can show you this your website quantlase.com/robots.txt. So this website whoso will develop, he put it user agent all means all search engine, and then disallow. That means only the home page can be accessed by all search engine, nothing else. Like that. So this allows the policies so that over flooding should not be there. Then inverted index, why it is better? Because it is going to have the terms and how many document that term is coming. Please remember, the common term can come in all documents. But in the logical view of inverted index, they don't consider it. They consider on the noun words. Noun is the main information extraction in any web document. So number of documents is coming, what is total frequency, and dictionary posting. So which term is happening in the which document. Like that, inverted index is there. Now, what is the logical view of the document? Suppose you have any web page. So there is a logical view. So in the logical view, you see, because we are going to study, read some content, there should be proper spacing. Because if not there, you will not able to understand the things. So in English language, so accent, spacing. Now there are the stop words. Stop words are the common words. Is the like that. Yeah, they are the part of the syntax. So they're supposed to be take care. Noun group we should able to, like with the help of POS triggers. Then there is a stemming. Stemming is run, runs, running. The root word is run, like that. So all these operations is going to perform, and finally we are going to have the vocabulary, distinct keywords. So maybe the one document is going to have 5,000 words, but the distinct vocabulary will be say 50 words only. So the 50 word can be used to represent that content. Then for information retrieval modeling, there is a quadruple framework. Like we are going to have millions of documents. At a time, user is going to have one query. Then there will be a framework and there will be a ranking function. So ranking function is going to have the query and set of documents. One query, now there will be n number of documents. So with the help of this framework, any ranking algorithm, and we are going to find out if on the basis of this query, this document is going to release. And this numeric score, highest score on the search engine come on the first, like that. So we are going to have many types of the data. You already read text, number, click, string, graph, table, images. So we are data files. So why machine learning? Certainly for automation. Wide application you can use it, transforming data into insights, better results, quicker decision makings, multi-variety information handling. We all are going to watch Netflix or other, and the success of Netflix is its recommendation algorithm. So with the help of this recommendation algorithm, what it is going to do, if we are going to watch one kind of movie or one kind of series, by tagging that this is the director, this is the actor or actress or producer, in the next time automatically it will going to suggest you can also watch this forthcoming movie or earlier came movie. And they are going to have more than 80% pages out of this recommendation algorithm. Meta, Facebook, image tagging feature. So all people are available if we are going to use the Meta, Facebook, and once we are going to put a picture with the help of its machine learning image recognition algorithm, if the user is available, it is going to do the auto tagging. You can remove that tag. So that is also pictures come with all the machine help. Imagine Alexa, like our personal assistant. What is the temperature? Play some song, something like that. Very helpful to us. Wake up alarm, so many things is going to carry out. And for testing, imaging, some blood tests, they are going to find out immediately by putting the sample if you are going to have this disease or not. So machine learning is important because to uncover pattern and trends in data, solving the complex problem, improve decision making, increase in data generation. So actually this machine learning is totally different from the traditional computer programming. So in the computer programming, we are going to have the data, we are going to write a program. Program is a set of instructions, and then based on input and data, it is going to do the computation output. But in machine learning, we are going to have the data. Then on the data, we are going to have some specific attributes, some labeling, and then we are going to train the data. And after training the data, we are going to show the new data to machine, and it is going to predict by applying some machine learning model. So machine learning is the study of computer algorithm that allow computer program to automatically improve through experiences. Experience is very important. Training is very important. So this machine learning is a subset of artificial intelligence, and so ability to learn without being explicitly programmed. And deep learning also come in the picture, learning based on the deep neural network, like started with a single neuron perceptor model, then feed forward neural network, then we are going to have the recurrent neural network, which is based on the backpropagation algorithm, or convolutional neural network. So this is just like the difference between the artificial intelligence, machine learning, but yes. So now artificial intelligence, machine learning, then subset is deep learning. We also going to have this prompt-based generative artificial, we will discuss later about it. So why this machine learning is hard for like we people are already having the experience, so we can identify this is apple, this is peach, or this is apple logo. But for machine, if we are not going to train, going to show the pictures with certain features, it is not able to define. So for solving any machine learning problem, we should have some objective, and based on our problem statement, we have to suppose to find out the data gathering, then we have to prepare the data, then we have to do the data exploration, then we are going to build a model, then we are going to evaluate the model, and after applying the evaluation, we are going to predict. And then it is working with the help of different matrices, accuracy, precision, half measure, sensitivity, like model, how model is predicting. These are the steps I have already. So this machine learning can have mainly three types: supervised learning, unsupervised learning, and enforcement learning. So in this supervised learning is of two types: classification and regression. Classification, we are going to have discrete values like classification, binary class, multi-class, but regression on some quantity. So this is the continuous in the nature. Then we have unsupervised learning. So here the data is labeled data. Whatever input features are there, we are also going to have the label. This is based on this feature, this is our labeled data set. But in unsupervised learning, we have the unlabeled data. So this can have the clustering, association mining, or dimensionalization by using the principal component analysis or singular value decomposition. Then we have the reinforcement learning. So like I asked you, supervised learning is this technique in which we teach and train machine using data which is labeled. So like suppose these are the 6 pictures and the pictures are already labeled, and we train a model, and then we are going to show the new pictures. If model is going to rightly identify like this picture is of Jerry or Tom, so we are going to say this is correct classification. Similarly, if we are going to have some labeled data for vegetables and they are already like defined, this is tomato or carrot or bell pepper, then we are going to train model. So generally we do like 70% training, 30% testing, and then on 30% data we are going to test it, and if it is going to correctly predict, we are fine. If it is not going to correctly predict, then again we do the retraining. So supervised learning, I have already asked, like classification, discrete labels, defined labels, regression, no label is defined, like classification problem. Will it be cold or hot tomorrow? So this is a classification problem. We just on a set of different like temperature is going to come as a cold, and one set of the another on the like hot. So now regression problem is what is the temperature going to be tomorrow? So again, it cannot be fixed this temperature quantity whole day. So it is going to vary. So it is a regression problem. Like classification, spam filtering. So we are going to use emails or Gmail now these days. This is enabled with the spam filtering algorithm. So many times this spam filter based on some classification, automatically it is going to classify this mail and it goes to the spam filter. So sometimes the genuine mail also comes to the spam filter. So again, some friend is going to say, and we are already asked, like see on the spam. So that is also a classification problem. Now to identify the high risk or low risk customers. So based on some income and saving, we can identify. So this in banking application, they are going to use whether they should give a loan or credit card to a specific customer by analyzing its data. Like you want to predict a cost of car or cost of a flat, so it will depend on the various parameters. So this is a supervised learning regression problem. Unsupervised learning, this learning is data is not labeled. So we have the data, but data is not going to have the output. Now we have to apply some clustering algorithm, and clustering algorithm, either the k-mean clustering or any other clustering algorithm, they are going to find out certain patterns, and then based on certain patterns, it is going to put in a one class, like say out of 6 pictures on the basis of color, or so that is the clustering. Say if that data is also, vegetable data is also not labeled, then it is going to, so output. We all are going to use the Google News. So Google News, they also use this clustering. So whenever we want to know on a specific keyword topic, so they are going to combine the different media channel uses on one platform. Suppose long back we use this COVID-19 or whatsoever, so they put all the different channels news on one place, so you can see and go through it. So astronomical data analysis, social network and market segmentation based unsupervised learning algorithm is going to use. Now come to the third category that is very important for reinforcement learning. So now in this reinforcement learning, there is an agent and environment. So now this agent is going to reward it or give penalize. So if some agent is going to behave correctly for solving certain problem for different path or task, it is going to reward it. Reward it means we encourage to repeat that task, that path. But penalty means wrong actions. So wrong action is going to capture with the penalty, and right action is going to capture with the rewards. So this self-learning Google Alpha game is going to use the reinforcement learning. So this reinforcement learning is like value-based reinforcement learning. So the popular one is the Q-learning, deep Q networks, proximal policy optimization, policy gradient methods. So there are 4 types of the reinforcement learning: value-based reinforcement learning, policy-based reinforcement learning, model-based reinforcement learning, hybrid approaches, actor-critic methods. So this value-based is very popular. Like value-based reinforcement learning focus on finding the optimal value function that measures how good is for an agent to be in a given state or take a given action. And I have already asked like Q-learning, deep learning. The advantage is simple and effective for small action spaces. Don't require a model for environment. So there are a lot of algorithms already developed. You can also develop your own algorithm, like for supervised learning, regression, linear regression algorithm, polynomial regression, decision tree classifiers, random forest algorithm, KNN classification, tree classification, logistic regression, naive-based, probabilistic-based support vector machines. Then for unsupervised learning, clustering algorithm, singular value decomposition for dimensional reduction, because we have to choose only the whatsoever, because all dimension for one application is not needed. One thing can have a lot of features, but that all features is not applicable for one kind of application. So different kind of application require different features, so we can do the dimensional reduction with the help of either the principal component analysis or singular value decomposition. So these are the few evaluation matrices we can use, like confusion matrix. So practically in machine learning modeling, we are interested in the predicting action. So either we are interested in true positive or true negative. Our model must be able to identify whatsoever is actually and it is going to predict. But it's not there, it should not be. But sometimes if it is actually there, but it is not going to identify, so we call false negative type 2 error, and it is not there, but it is going to identify, then we call the type 1 error. So always a model should not have the type 1 or type 2 errors, should have this. So we are going to have the precision and accordant machine learning matrix, true positive upon true positive plus false positive. Then error for a machine learning model, this error must be minimum. These are the different matrices which is going to use to compute the error. So there are many applications of the machine learning. You can see in the automated language translation, Google is going to use medical diagnosis, stock market trading prediction, online fraud detection, virtual personal assistant, email spamming, self-driving car, product recommendation, traffic prediction, speech recognition. I've already asked about the Facebook auto tagging feature. It is going to do it. These are the different application, and all are going to have the application of the machine learning, which is going to be used by the Meta. Google Translator, this is also one application of the machine learning. So with the help of translator, phone numbers. So many times we go to some country where like driver or people's store, they are not able to understand our language, so we are going to use the translator. Google voice search, we are going to use it. Google Photos. Now these days, with the help of this natural language processing, Google Smart Reply is there, so we are going to have some email automatically. Google Map optimization problem. That is also the application of the, whenever we are going to have congestion on one road, immediately its algorithm is going to provide the shortest path and without them. Alexa, I have already asked you. Netflix, I have already asked. Fake news detection also, machine learning is going to use. So, because all of us, sometimes on our WhatsApp or by other, we are going to receive some information. So, please help us to take care of the source. What is the source of the information? Who's the author? So, if author is tick one, verified, or we have to also check a date. Sometimes the video comes, the old videos are there, but then check your bicycle. So we should do it. Suppose something we receive some information, we can do the Google. In Google, all the links are showing that information. That means the high probability that news is the true news. Only that we are not able to see. That means there is a high probability that news is the fake news. So read beyond. So I have already asked. What are the supporting sources? It's a joke. And there are many fact checker websites are also there. So on fact checking website you can do the checks. Online fraud detection, machine learning is going to use. Stock market prediction, machine learning is going to use. Medical imaging, computed tomography, radiology, this machine learning, convolutional neural network, long short-term memory, different neural network. GANs is going to be used to create more and more images. And so now these days, many industries is going to use manufacturing, predictive maintenance, retail industry, healthcare, life sciences, travel and hospitality industry, financial services, energy, stocks, utilities. So now we are in the Quantlase. So now the quantum computing effect, big model creation, distributed machine learning, portability, low code environment with the help of like ChatGPT, or now no need to write a code, just you have to one prompt, you have to say write this program or create this, it is immediately going to do. So what are the hard computation problems? We are already aware, like hard computation problem, those that cannot be solved efficiently using the classical algorithm due to their complexity, like in NP-hard problem, traveling solution problem, knapsack problem, Boolean subset problem, combinatorial optimization problem, high dimensional problem, real world complex problems. These are the few examples of, so these are traditionally in mathematics, like traveling such problem is we have to travel from one city and we are going to have many cities, so there should be one starting city and we have to cover all the city at least once and these two the finally starting city. But what is the like minimum time and cost and all that things. Now these days in generative AI, you all are aware like generative AI, sometimes called the Gen AI, is artificial intelligence that can create original content such as text, images, video, audio, software code also respond to the user prompt or request. So generative AI operates in the three phases: training, tuning and generation, evaluation and returning. So this is also the part of machine learning I have already asked you. Now these days many companies are working in the area of generative AI. So you can see for consumer reflection, for open multi-purpose Google Gemini or OpenAI, Meta AI. So there are a lot of natural language technology. Tokenization means we have content split into the different content, stopper, removal, algorithm, topic modeling, so that we can find out like specific content is related to this topic, sentiment analysis like positive sentiment, negative, name entity recognition, word embedding, machine translation, term frequency in the natural language processing. Term frequency means like in a document a term is occurring how many number of times. So this is called the raw frequency. But we don't consider the raw frequency, we consider the logarithmic frequency, 1 plus log these two fn. So and again we don't consider like two document. In a one document, one content is coming 100 times, one term, and another document is coming say 10 times. It doesn't mean the document which is having a term appearing 10 times less important. So we do the inverse document frequency, then we do the document length calculation. So many things are going to do so that we are going to identify like this specific document is highly related. Now these days there is a very important like quantum machine learning. So in I think 2017 this quantum machine learning. So quantum machine learning emerging field combine principle of quantum computing with machine learning to solve complex computational problems more efficiently than classic methods. So speed up in computation, handling high dimensional data, optimization, quantum features. So there are a lot of benefits by using this quantum machine learning. Quantum machine learning can speed up the training time. Quantum machine learning can use quantum tunneling to get the true objective instead of gradient descent. Quantum machine learning can represent more complex network topology. Quantum machine learning can automatically adjust the hyperparameters. Quantum machine learning can perform complex metrics at some high speed. There are many quantum machine learning algorithms, linear algebra simulation, search algorithm, quantum analysis learning, quantum annealing, quantum neural network, hidden quantum macro models, pattern matching classification, and sampling techniques. So this quantum machine learning is also going to have the similar application, but certainly if we are going to use that will going to have the time will be going to take a less. So financial modeling we can use, optimization problem we can use, artificial intelligence, material science. These are the few softwares if somebody would like to work or working in the area of machine learning. Weka, Apache Spark Machine Library, Rapid Miner, KNME, TensorFlow, Google Keras, PyTorch, Apache Moho, Google Cloud Machine Learning Engine. So machine learning approach for NP hard problems, deep learning for optimization can be used, identifying hard instances, mixed integer programming, enhanced approximation algorithm, and how machine learning helps in solving computational hard problems. So we have to learn smart search strategies. Think machine learning as a guide for search algorithms. Techniques, reinforcement learning, learn by training, supervised learning, learn from experts, label data. Benefit faster, more efficient exploration of solution. Pick the right algorithm automatically. Think machine learning is an algorithm selector. Techniques, supervised learning, predict best algorithm based on problem features. Benefit, no manual guessing, best tool for each problem. Most existing algorithms. Create fast, fake problem. Simplify problem before solving. Machine learning as a problem preprocessor. Machine learning to analyze, simplify complex problem. Makes problem easier for additional solution. So this is just supervised learning for algorithm selection, machine learning as a problem preprocessor, boosting algorithm, and reinforcement learning for statistics. And there is a very important quote given by Larry Page. He is the co-founder of the Google search engine. Like what will be the ultimate search engine will understand exactly what you need and give back exactly what you want. Still they are working already, like we are going to have. Like in search engine, actually there's a lot of difference between the search engine, long time we are using, and say ChatGPT or other, because they are not going to provide you the general sources. Already we heard like DeepSeek, they are going to provide the sources, because again, like if we are going to use some data for our work purpose, then we should also know from where we got it. Because on ChatGPT, it can do something for us, but we are not, what is the source? So the analysis, maybe for quick solution is there. But whenever we are going to solve, we should have the exact source of the information. This is all about, sir, give me the 45 minutes. I think, so that is why I hurry up, otherwise going to take the 2 hours. I think I just try to give you some like basic, so everybody can understand. So thank you very much.
Thank you very much, Dr. Dilip, for giving a flavor about the machine learning and all. So it's very hard to digest to me about learning, because it's my personal opinion, learning cannot be intelligent. So through learning, one cannot be intelligent. Or gathering a huge data, you can be smart, but you cannot be intelligent. That is why you are calling your mobile is a smart device, not intelligence device. Because infinite data you are gathering continuously day by day. So you could be smart, but you cannot be intelligent. So my question is that where does this intelligence come from? Is the intelligence comes from your training by data, supervision, reinforcement learning, whatever? Is coming from the training or is coming from something else? So this question is still open. So intelligence and brilliance is two things. So one can be a brilliant by training, by understanding, gathering large number of data. So but intelligence is not something like that one can extract from somewhere. It's, I don't know where does it come from. So how this intelligence is related to the consciousness of the system. How conscious your system. And again there is a problem. The people are talking about the solving hard computational issues. So my question is, how hard is hard? So this hardness is coming from you are unable to solve, or you don't have resources to solve this problem. That is why you are calling hard. Or this hardness is fundamental hard, because it's a fundamental nature of reality. So either we are solving to fundamental nature of reality, or we are solving our resource problem, funding problem, or other problem just by saying that this is hard. So I'm a bit confused in this regard. So by quantum, people are using quantum term with everywhere, quantum learning, quantum AI. But what exactly is quantum? Quantum is not easy to understand. Quantum is not something like that you can make a classical rule on it. So it's beyond your classicality. So quantum is the probabilistic world, and how this probabilistic world or the possibility converted into predictability. So we are living in classical world, and classical is predictable world. So we we need to make a bridge between the possibility to convert it into predictability. So possibility word is not like something where we can write a mathematical function, you can write some algorithm on it. It's a nature, it's fundamental nature of reality. And the microscopic world is behaving in a different way. What we are living in the classical world is different. So we need to make a bridge between classical to quantum world. And how to make a bridge, this is a problem. Because the problem is your wave function collapsing problem, because quantum world is actually behaving as a probability and it's a wave function, but once you detect it is collapse. So you are losing the quantum feature. Of course you are getting something, but it's not really a quantum. So there are two ways, either you get it into quantum world or there is something, the information bring from the quantum to classical. But the problem is same. Classical world is not like a quantum. You cannot understand quantum at classical world. So it's something like that, the observer being observed itself. So intelligence, quantum, and something else, consciousness, these three terms actually very difficult to digest. Quantum, intelligence, and consciousness. And other thing is that because AI person are dealing the issues, hard computational issues, and blockchain person are doing same thing, quantum person are doing same thing. So task is to solve hard computational issues. But what are the hard problems? What is hard? Anyone can mention this is hard, cannot be solved by classical computer. So what is the hardness? Hardness is not just a process, speeding up the process or finding something or calculating something. So what is hardness? Hardness is something like that which is not possible to solve classically. Classically means like the probability of finding someone somewhere, everywhere at the same time. How to find it? Like if finding the position of electron around the nucleus. So you cannot find a position instantly, something one position. You always see the cloud around the nucleus. So what does it mean, cloud? Cloud means you are actually trying to gather all the information of finding this electron at different point. So you are continuously doing your experiment and find the cloud. So it's because there is a issue with on the one hand you say that okay, when you try to find the quantum particle, but the moment you try to find it, it's not there. So this particle is not there or you are unable to find it. So maybe you are trying to catch this particle that moment, at that moment that particle could be somewhere within the same orbital. So it's not something like that you are trying to detect it and the wave function is collapsed. It's something else, there is possibility something else. So there are many issues actually with quantum. Quantum is a fascinating term actually. Yes, but reality is different. So we need, it's an enduring challenge to study and understand of quantum phenomena at microscopic or subatomic level. So understand it and extract the information about it, and then try to think about the implement in real life application. So learning is a different task. Brilliancy is a different task. Learning means you learn something. It's your experiential understanding, but it's not your intelligent understanding, because intelligence is directly related to the consciousness, how conscious you are. Training is different. It's based on data. Whatever data you are using, trained, supervised, rainfall, whatever. So we need to think about it, and we need to change the way of dealing the problem using quantum infrastructure, including or integrate AI with because three things, they are not working separately. Some part of the problem one can solve by AI, means like training and all, but some other part like process, speeding up the process. AI, whatever AI model you are using, it's finally classical. It's finally a digital. It's not parallel. You cannot say I'm training my data parallelly, because parallelism comes from the light or quantum behavior. Parallelism will not come from the classical behavior. So the way you are changing to look at the problem, but it's not quantum. So quantum is for you are dealing the issues parallelly at the same time. It's something like that. You have a 100 marble ball and you put one marble ball over there. And classically what you will do, if I ask you, can you hit this ball? So you classically hitting one by one. And it will take 24 hours, you never hit. But sometime it will, one shot you can hit. But it's a classical way. You are sequentially doing. But if you throw 100 balls, same time, so definitely there is a 100% probability hit one ball with one. So how to create this infrastructure in lab? So this 100 possibilities you have to create in the laboratory, and there is how to create that. This is the quantum science. So either you trap atom or you trap ion or entanglement state, whatever. There are a lot of process, but you have to create all the possibilities at the laboratory. Then you use this possibility to hit the problem. So some part of the problem can be solved by AI, some part you can deal with the quantum, and of course some other part classically, because we cannot totally get rid of quantum classical infrastructure. We have 70% is electronics in our laboratory and everywhere. So you cannot get rid of this thing. So better to avoid of this available resources, better to use it. So we need to integration our available resources like electronics and of course quantum, and the algorithm side is AI. Then all together there is three things, and then you are able to make a something which is cutting edge, path breaking route to solve the problem. So this is my opinion and my feedback.
Absolutely correct.
So that is thank you very much for your nice talk. And if anyone has question from AI group. No?
You can share your problems, my research team is there, so
Yes.
definitely we will try to give some support.
Yeah, that is why you are here.
We are
trying-
PhD full-time scholars, masters.
Yes, yes. So
we will-
we are dealing with something related to data over here,
So,
and
you
we
give us
always
a-
interested to
we will
find
give you
someone
another
to.
question.
Yes, Dr. Reza.
This unsupervised learning,
Yeah.
is it somehow can be applicable for anomaly detection?
Yeah, it will depend on we can apply unsupervised learning also if the data is not available. So we can
Like what I mean, that if you train your data for some like normal condition, would the algorithm will understand an abnormal condition later?
Yeah, we can do it. Actually, what we do unsupervised learning. Then, if we are going to form clusters, then finally we also apply the supervised learning. Once we are, because again we have the similar things now, a similar category. Then we do the supervised learning. It's not like because we are going to have one kind of cluster or one kind of the groups. And again, that is
Isn't that the classification? So you classify your training data, and then you ask your algorithm, okay, now based on the train data, now we classify the new data. But I'm mainly I'm asking about the anomaly detection, which we might don't have any data for training. We just can train the algorithm for the normal data.
Yeah.
Would the algorithm will later understand if it is something new, whether this is normal or abnormal?
Yeah, so you can
Finding anomalies is actually many people are fighting. Many people are facing this problem, finding anomalies within the data without supervision.
If we supervise it for normal data, then there comes a situation which is new for the algorithm, how it can kind of understand whether this is abnormal or normal. That be possible? For medical application, I'm telling. Or image-based application.
That will be depend on the data set. If data is, you ask like data set is not labeled, then we will apply some clustering algorithm, and then we are going to have different clusters, and on the basis of cluster with their properties we are able to define, like suppose credit card fraud detection. Again, there is a pattern. Like you are going to have X income, then say you can spend 60%, 40% you can save, but you are having X income, you cannot save 100%, or based on the previous historical pattern. So it will depend on the data set.
But in addition to you, suppose you are looking for some attribute or some elements, and you want to say that whether this is normal or abnormal. So first of all, suppose you capture some image, and image itself don't have that feature, and you are looking for, so whatever AI, whatever quantum you will use, it will not find out, because your image don't have that feature, and your experimental detection system is not capable to detect. So it's not a question of processing or AI, it's a question of how precise or how accurate your system is giving this information to your data, to your
but human is intelligent enough.
that is why in the beginning I said that system is not intelligent.
But that's our ultimate
Human
goal
is
with AI,
intelligent.
right?
So really like there is a quote, but like computer is not intelligent. We people are intelligent. We make
That is why
computer
intelligence is not brilliance, is the smart way to deal with the things, but it's not intelligent way. Intelligence is different. So that is whatever data you are using, whatever procedure you are using, supervision, reinforcement learning, whatever. If that particular thing is not available in your data, your computer will not create. Because computer is not intelligent. So it's depend on your data, finally. The smartness, your smartness is just to reorganize the data and just to try to find out some pattern or anomalies. It's your smartness, but it's not intelligence. Intelligence is something like that which is not there and you are able to find out. So how does this intelligence get involved in your infrastructure? So to the best of my knowledge and my experience, only light, the manipulation of light, you can create that intelligent way to get this something. Because you have to manipulate and control your light depending on your requirement. So it means you have to make your system intelligent, not detection system. So this is the things actually. So thank you very much everyone, and we need to have a group photograph.